Okay, class. Hi, this is Professor Goldstein. We're going to talk about section 4.3. This is the repeat of the lecture I did that did not record last night, so that was a lot of fun for me. So hopefully I have better luck today. Okay, so section 4.3 talks about the method of undetermined coefficients for higher order ODEs. So you remember our general higher order ODE is something you can write in the form the nth derivative of y times a constant. So these are constant coefficients. So all the AIs are just real numbers. So it's a linear combination of the nth derivative and all the lower order derivatives of the unknown function y. And the undetermined coefficients applies to the case where you have an inhomogeneous term. In other words, you have a function g of t, which is not zero. If the function is identically equal to zero, it's a homogeneous equation. And we talked about how to solve nth order equations when they're homogeneous in the earlier section. Okay, so when we did second order equations and we used undetermined coefficients for the inhomogeneous equations, it worked exactly when the inhomogeneous term was sort of one of three cases, either a polynomial, an exponential function, or it was sines and cosines, or it was, or a combination, a combo of all three. Because you could solve, if you had a combination of three pieces, you could solve for the particular solution in each individual case and then add them up. So we'll see an example of that in our third example that we considered today. Oh, I had that written. Okay. All right, so let's begin. We're going to do this in the context of three examples. So I start with the equation, the third derivative minus 3 times the second derivative, and so on, is equal to 4e to the t. So notice 4e to the t is an exponential term. All right, so that's a setup where undetermined coefficients may work. So now we have to chase through and see. As we did with the second order equations, the first step in solving an inhomogeneous equation is to solve the associated homogeneous problem, because we know that the general solution to the whole problem is going to be the solution of the homogeneous equation plus one particular solution of the inhomogeneous problem. So the first thing we do is we look for the general solution of the homogeneous equation, the y sub h. And when you solve an equation like this, as we saw in the earlier sections, the first thing you do is write down the characteristic equation. So every derivative becomes that power of lambda. So I just copy it down, derivatives become power, the zeroth derivative gets the zeroth power. Okay, and so now that's something we have to figure out the factoring of this by using synthetic division. So all the possible numerators for the roots are the possible factors of -1 here. So that's plus or minus 1. The possible denominators for the roots are all the possible factors of the coefficient of the highest order term. So again, that's only plus or minus 1. So all the possible roots are the possible numerators divided by the possible denominators. In this case, that's easy enough. It's just plus or minus 1. Okay, so we start the synthetic division. So you write down the coefficients from here. Okay, so I did this calculation while I was lecturing to myself last night. You bring down the 1, and then we start. 1 times 1 is 1, and you add, you get -2. -2 times 1 is -2. You add, you get 1. 1 times 1 is 1. You add, you get 0. When you get 0, that means bingo. That was a root. So 1 is a root. So lambda minus 1 is a factor. So we write down our original polynomial, that we want to set equal to 0. This is equal to 0. Remember, that's our characteristic equation. Now we have that lambda minus 1 as a factor, and what's the remaining term? This tells us what the coefficients are. So our original equation was, original polynomial was a cubic. This one will start with a quadratic. So you get 1 times lambda squared minus 2 times lambda plus 1 times lambda to the 0. And then from basic high school algebra, that's lambda minus 1 squared. So altogether, you get lambda minus 1 cubed. So in other words, 1 is a triple root. So when I go to write down the homogeneous solution, what are the 3 linearly independent solutions corresponding to this triple root? Well, that is y1 is e to the t, y2 is te to the t, because you multiply by t when it's a double root, but it's a triple root, so I got to do another power of t. So that's a t squared e to the t. And now we have our 3 linearly independent solutions of the homogeneous equation. Okay, so that means the solution to the homogeneous problem, I should call that y sub h, is c1 e to the t plus c2 t e to the t plus c3 t squared e to the t. Okay, good. Now we have the solution to the homogeneous part. And now we have to start to look for y sub p. Okay, so when I look at y sub p, now, whoops, let me go back up where you can see it. Our inhomogeneous term was e to the t, a constant times that. But look, e to the t by itself is one of the solutions of the homogeneous equation, as is te to the t and t squared e to the t. So we can't guess just e to the t. That one would give us a right-hand side of 0, so that won't work. And same thing for t power and the same thing for t squared power. So the first power that we have a chance at making it be the solution to the inhomogeneous equation is to multiply by the cubic. Okay, so I guess a t cubed e to the t. Okay, so now I have to start to calculate the derivatives and plug into our equation and see what a works out to be. So when I differentiate this guy, I'll get by the product formula at cubed times e to the t, because I differentiate the e to the t. And now then I'll get e to the t, and you differentiate at cubed, and so you get 3at squared. And now when you differentiate again, differentiate this guy, you'll get at cubed e to the t plus 3at squared e to the t. And now when I differentiate this one, I'll get a 3at squared e to the t plus a 6at e to the t. So now I just combine that again using some algebra, and I get, here's my second derivative. Okay, and now we differentiate one more time. Okay, so when you differentiate again, you get a bunch of terms. I'll leave that for you to check that this is correct, but it is. Okay. And now when you combine it and write it a little nicer, now we get that the third derivative looks like this. Okay, so we have our third derivative. Let me see if I can get all this to fit together. We have our third derivative, our second derivative in a nice form. The second derivative in nice form is here, and the first derivative is here. So we plug all that into our equation. So our equation that yp has to satisfy is 3yp triple prime. This is our original equation. This should be a y sub p here. And that has to be equal to 4e to the t. All right, so notice that everything, every single term in the triple derivative, the second derivative, and the first derivative, every single term has an e to the t. So I'm going to factor that out. So now I write down, I'm factoring out the e to the t, and I write down the coefficients I have in the third derivative term. So that gives me a 3a, an at cubed. Then I get a 9 combining, combining these two. I get a 9at squared times e to the t, but that's factored out. And then combining these two, I get an 18at, and then I have a 6a. And now I have to take minus 3 times the second derivative. So again, you factoring out the e to the t, I have a minus 3 times at cubed plus 6at squared plus 6at. And then I have to take 3 times y, I have to take 3 times yp prime. So again, factoring out the e to the t, you have an at cubed and a 3at squared. And then you subtract the yp, which is at cubed times e to the t. And all of that has to be equal to 4t. All right, but the distributive properties work in here. So right away, you notice that you get a minus 3at cubed up here and a plus 3at cubed here. So this one and this one go. Okay. And now let's see what else. For the t squared terms, I have a 9at squared here. Here I have a minus 18at squared. And then down here I have a 9at squared. So this one and this one makes 18t squared, and that one is a minus 18t squared, so that's gone. And then notice I have an at cubed and a minus at cubed. Okay, so let's see, what is left? I have an 18at, and then here I have a minus 3 times 6at, so that gives you minus 18at. So those two go. So the only thing you're left with, so I'd written it out longhand here, okay? So the only thing you're left with is 6a has to times e to the t has to be equal to 4a to the t. So 6a has to be equal to 4, which says that a is equal to 2/3. Okay, so now the general solution to our inhomogeneous problem is you take the general solution to the homogeneous problem and you add the particular solution we just found. Okay, so it's not really hard, it's just a lot of bookkeeping. Okay, so that's one example. All right, now let's look at the next example. I want to do one where the right-hand side involves sines and cosines. Okay, so let's look at this equation that I've written down here involving a fourth derivative. And the right-hand side is 3 sine t minus 5 cosine t. Okay, we start with looking at the associated homogeneous equation. And then I write down the characteristic equation. So that's lambda to the fourth plus 2 lambda squared plus plus 1 equals 0. And notice if you think that s is equal to lambda squared, then this equation is s squared plus 2s plus 1 equals 0. So it's a quadratic in lambda squared. Okay, so you factor it. If you factor this thing, it factors to s plus 1 quantity squared, but s was lambda squared. Okay, so this factors to this. And so when do you get a solution to that? When lambda squared is equal to minus 1. So that says lambda is equal to plus or minus I. And since lambda plus 1 was squared, the two solutions, plus and minus I, each is a double root. Okay, each one is a double root. So we have to take into account that when we write down our solution to the homogeneous equation. Now, for each root I, you get two solutions, right? Because you think of that as a complex number, alpha plus or minus beta I. And for this one, alpha equals 0 and beta is 1. Okay, so that means one solution is e to the 0 cosine t, and another solution is e to the 0 sine t. But each one's a double root. So I have, in addition, two more linearly independent solutions t cosine t, and t sine t. Okay. So that gives me my 4 linearly independent solutions to a fourth order equation. That's all of them. And now, so when I write down the general solution to the homogeneous equation, you just take a linear combination of all these 4 solutions. So that's what I have written right there. Okay, good. Now we're done with the homogeneous problem. Now we have to look for a particular solution of the inhomogeneous problem. But I remind you that my inhomogeneity was sine t and cosine t. But both of those are solutions. In fact, they correspond to a double root of the homogeneous equation. So when I guess a particular solution for the inhomogeneous equation, I can't guess a constant times sine t or a constant times cosine t because that already solves the homogeneous one. And I can't guess t times it because, again, that solves the homogeneous one. So I have to go to t squared to try to get a solution to the inhomogeneous problem. All right, and now the differentiation becomes really messy. You need to find yp prime, yp double prime, yp triple prime, and yp to the fourth. Okay, and then you plug it into the equation and you work that out. And I'll leave that for you to check and to make sure you can do the algebra. If not, we can discuss it in detail the next time we meet online. And you'll get that C1 is 3/8 and C2 is 5/8. Again, it's messy, but it's not hard. You just have to be a good bookkeeper. All right, so once you do that, you found these 2 constants. That means you have exactly the particular solution. And so you can put together everything you know and get the solution to the general inhomogeneous problem. That is, the general solution to the inhomogeneous problem is the homogeneous solution plus one particular solution that you found. So here's my solution. This part and this piece is y sub h. And then the particular solution, after you evaluate the constants, the part we skipped here, is 3/8 sine t plus 5/8 cosine t. Okay? All right. So the important thing, the reason to mention this one is even though this looks like your guess should be a constant times sine t and a constant times cosine t, since that and t times each one of those is a solution to the inhomogeneous problem, you can't guess yp to just be sine t or t sine t. And the same thing with cosine. You must go to the next power higher of t times those things. Okay. Okay, so the last example I'm going to do in this section is one where we have a triple inhomogeneous term with 3 pieces. Okay, so we have an inhomogeneous term with a polynomial, a trig function, a cosine, and an exponential. Okay, so the first thing we want to do is solve the homogeneous equation. So we write down the characteristic equation. Okay, and now when we factor it, we get lambda times lambda squared minus 4, which factors to lambda times lambda plus 2 times lambda minus 2. So our 3 values of lambda, the eigenvalues we get are 0, plus 2, and minus 2. Okay, that one was easy. So that means our homogeneous solution is C1 times e to the 0t, C2 times e to the 2t, and C3 times e to the minus 2t. Okay, good. That one was really easy. Now we have to try to solve the inhomogeneous problem in 3 pieces. You do each one individually. So you do this one, then you come back and you do this one, and then finally you go and do that one. And then you add them all together. Okay, so let's look for a solution to our equation equals t. Okay. So when you have a polynomial like that, you want to, and because 0 is already an eigenvalue, you're going to guess a plus bt times t as as your particular solution. Okay. So when we guess that, now we differentiate. So yp prime, y1, yp1 prime is this, yp1 double prime is that. Okay. And then yp triple prime is just 0. So now we plug into our equation, which says that t has to be equal to yp1 triple prime minus yp1 prime. Triple prime is 0. Minus 4 times yp1 prime. So that'll be minus 4a minus 8bt. So the equation says t is minus 4a minus 8bt. And now equate coefficients. What's the constant term on the left? It's 0. So that says a equals 0. And what's the t term on the right? On the right, it's 1 times t. On the left, it's minus 8b times t. So minus 8b has to be equal to 1, or b is 1/8. So we have a equals 0 and b equals 1/8. So our particular solution for this equation, which is the first inhomogeneous term, is minus 1/8 times t squared. Okay, because we found a is 0 and b is minus 1/8. Okay. Now we play the same game with the second inhomogeneous term. That's the 3 cosine t. Okay. Now, cosine was not doesn't come up from one of the eigenvalues we had. The t came up because it's 0. You had lambda equals 0. And so it could be C1, which is a constant, or now you have to do t times that. So that's how we got the other one. But now with cosine, that is not, cosine is not, would come from an eigenvalue of plus or minus I. And we don't have that. These are the only 3 eigenvalues. So we can just guess that the second particular solution, that is the one that satisfies this equation, can be of the form a cosine t plus b sine t. And now we just have to differentiate and work out what that is. So I differentiate, I get yp2 prime, yp2 double prime, just differentiating, yp2 triple prime, and now I plug into this equation. So when I plug into that equation, here's yp, this is yp2 triple prime right here. Okay, and now I have to say minus 4y prime, yp2 prime. So minus 4 times minus a is plus 4a sine t, and minus 4 times b cosine t gives you a minus 4 cosine bt. And that added together has to be our inhomogeneous term 3 cosine t. All right, so now let's equate coefficients and see what we have. This gives me a 5a sine t minus 5b cosine t on the left, and that's equal to 3 cosine t. So now you equate coefficients. What's the coefficient of sine on the left? It's 5a. What's the coefficient of sine on the right? It's 0. So that says a equals 0. What's the coefficient of cosine on the left? It's minus 5b. What's the coefficient of cosine on the right? It's 3. So minus 5b equals 3. So b is, this should be a minus 3/5. Okay, minus 3/5. Okay. Okay. And so yp2, that is a particular solution to the same equation with only the inhomogeneous term 3 cosine t is this one, minus 3/5. And remember, the a is 0. A was the coefficient of cosine, and b was the coefficient of sine. So it's minus 3/5 sine t. All right, and finally, we have to solve our same equation with the third and final inhomogeneous term. Now, e to the minus 2t, e to the minus 2t was one of the solutions to the homogeneous equation. So I cannot guess for my YP3, I cannot guess e to the minus 2t, because when I try to differentiate that and plug it into the equation, I can't get this right-hand side. I keep getting 0. So you multiply by t and try to see what happens then. Okay, so here's what I guess my solution to be. Now I have to differentiate. So I find YP3 prime, YP3 double prime. I simplify it a bit. Now I find YP3 triple prime. Then I write it out in better form with algebra. Okay, so now I have YP3 prime, triple prime. Here's YP3 double prime, YP3 prime. I plug it into my equation. So remember, my equation says you take the third derivative. So I take this one, and everything, notice everything has an e to the minus 2t. So let me just factor that out. So from my third derivative, I get 12a minus 8at. So this is from YP triple prime. Okay. Then I have to take minus 4 times YP3 prime. So that'll give me a minus 4a times e to the minus 2t plus 8a t e to the minus 2t. And that has to be equal to the inhomogeneous term I had, which was e to the minus 2t. All right, so right away you see minus 8at and plus 8at, those cancel. So this gives me 8, well, first of all, I'll divide this equation by e to the minus 2t. And then I get 8a, which is on the left. And when I divide by e to the minus 2t on the right, I just get 1. So that tells me a is 1/8. So the solution to the the solution to the third piece of the inhomogeneous equation, that is the one with the right-hand side being e to the minus 2t, is 1/8 t e to the minus 2t. Okay, and so finally, now we are ready to put all of that together. And I seem to, oops, maybe here it is. Okay. So now we put it all together and get our general solution. Here's my y sub h. This was the solution to the homogeneous equation. You can look back and see that that's what we had before. Here's the solution. This is YP1. This is the solution to YP2, to the second, and then here's the solution that goes to YP3. Okay. And basically, we're using the fact that if you have an inhomogeneous equation and two inhomogeneous terms are summed, then the solution to each one individually is the same as the sum of the two solutions, solution of the two inhomogeneous equations. Okay, so which was true for the second order case as well. Okay, so that's it for section 4.3. And so you should try some of those problems. It just takes practice and good bookkeeping skills.